Good morning, ladies and gentlemen. How are you going today? So today we're going to look at curve sketching. So it's an application of double derivatives or second derivatives. So recap of last lesson. Last lesson we introduced the idea of concavity and points of inflection. Essentially it was summarized in these two tables here where we could have a concave up function where your first derivative, your gradients or your first derivatives are increasing, and then so your second derivatives are positive because that's the rate of change of your gradients. Or you could have a concave down shape, which is like a sad face, where your gradient values are, well, your first derivatives are decreasing, and then hence your rate of change of your gradients, your double derivatives, is negative. And then we introduced the idea that, well, if your double derivatives are zero, and the sign changes to either side of your y dash dash, your second derivatives, then you either have a point of inflection or a stationary point of inflection or a horizontal point of inflection. So we've got to put that to use today where we're going to sketch some curves. So it's not entirely new because we've sketched curves before in Unit 1 and Unit 2. For example, we started off with quadratics like x squared, then we moved on to sketching cubics and then quartics. Back then, we used y dash, the first derivative, to work out our stationary points. We're just going to go into a bit more detail because now we have the concavity to consider as well. So let's have a read. It says here, stationary points, points of inflection, and derivatives. So remember, a stationary point is where the gradient is zero. In other words, your first derivative equals zero. Remember, we had local maximum turning points, so that's your sad faces because you're maximal worry, so you're bad. And then you could have minimum turning points, so you're happy because you've got minimal worries. Or you had stationary points of inflection, so that's these ones here, usually occurred in cubics or higher orders because that's the point where it's flat. There. Open the page. When we looked at the stationary points by solving for y dash equals 0, we always had to consider the nature of the stationary points as well, but looking at how the gradient changes to the left and right of that stationary point, or we could use the double derivative to consider that as well. So these 4 dot points are essentially summarized in the table below. So what it says here is, at a maximum turning point, the curve is concave down. Well, we knew that already. So at a maximum, or a sad face, right, a sad curve, because you've got maximal worries, your first derivative, or your y dash, is 0, because that's the gradient here at this point is flat. And your y dash dash, because you're sad, it's negative. So the way I remember it, if your maximum, it's maximal worries, and then it's sad because you've got so many worries, and so you're negative as well in your second derivative. If you had a minimum turning point or stationary point, again, your first derivative is still going to be 0 because at this point your gradient is flat. Now, because we're happy, we've got minimal worries, so minimal worries, so you're happy face, smiley face, and it's a positive thing, it's a good thing, so your second derivative is positive. And then you had a horizontal stationary point of inflection. That's when you had your point of inflection, but then the gradient at that point is flat. So obviously it could go this way or it could go the other way. So obviously it could go that way too. Again, your gradient is equal to 0. Don't know why I'm writing in red. Let me just change that. Your gradient is equal to 0 because at these points, at these stationary points, your gradient is flat. And because it's a point of inflection, so remember from last lesson, if it's a point of inflection, your second derivative is 0. And your y dash dash changes sign on either side. So it's either a negative plus, or you can have plus negative as well for your y dash dash. And then the fourth option you could have is a non-stationary point of inflection. So at this point, your gradient is not equal to 0. So it's a point of inflection, but it's not a stationary point of inflection. So your gradient at that point is not flat. It's not 0, it could be any direction. But your double derivative, your second derivative equals 0, and your y dash dash changes sign on either side. Again, plus, minus, or minus plus. So you could have four possible key features to check. So for starters, you would always check, well, is my first derivative 0? Is my gradient at that point 0? If it is 0, then we call those stationary points, right? So these are the first three because the y dash is 0. So these are stationary points. So y dash equals 0. Now, depending on your second derivative, you either get a sad face, a maximum, because that's Maxwell worries. So your second derivative is less than 0, it's negative. Or if your second derivative is positive, then you get a happy face because it's minimum. Or if your second derivative is 0 and the sign changes in either side, then you get a point of inflection, and it's also a stationary point of inflection. Or if your if your first derivative is not 0, so your gradient at that point is not 0, but you do have an inflection point where your second derivative is 0, and the second derivative changes sign on either side, then you have a non-stationary point of inflection. So those are the four key features you need to check as well. So in terms of curve sketching, we use the first and second derivatives to let us see what features we need to sketch or what features the function has. Remember, the first derivatives gives us the gradient or the slope at any point. The second derivative gives us the concavity because it's the rate of change of the gradient. And that's what we were talking about last lesson. So if we consider this example, our starting function, our y function, is a quartic because it's x to the 4. If we find the gradient, then it's a cubic because it's first derivative, and then the second derivative is a quadratic. So you've got them illustrated in 3 graphs here. So originally, it's a quartic that looks like this. There are 3 key features. You have here a stationary point of inflection. It's a point of inflection because it changes signs, changes the shape from a concave up to a concave down. And it's a stationary point because at this point, the gradient there is 0. So let's rub that off. So this point here, 0, 10, is a horizontal stationary point of inflection. At this point here, it is a point of inflection. It's not stationary though because the gradient at this point is not flat. But you do know it is a point of inflection because it goes from concave down and then switches to a concave up down below. So this here is a point of inflection. And down here you've got a turning point, a stationary point. It's a happy face, so it's a local minimum turning point or stationary point. Local minimum turning point. Now if you look at the graph below, this is y dash, so this gives us the gradients. So it's the gradient at those specific points. If you think about it, the gradient at this point is flat, so that corresponds to a 0 value for the gradient. So this here, the gradient is flat, so the corresponding gradient value is 0. At this point of inflection, we knew that the first derivative is not 0, right? And then the sign changes on, and then we'll see later on that the second derivative changes sign on either side. And then we'll see here that because the gradient here is flat, you have a y value of 0, so it's a flat gradient. And then down the further graph below, so that gives us the concavity test. You'll see here that the sign of the y dash dash, so here it's negative, whereas here it's positive. So you know it's a point of inflection back up at this point to -6, because the first derivative was not 0, but then the y dash dash changed signs on either side of that point. Yeah. So down here, the blurb, it's important. So because this is essentially a list of things you should do for sketching curves, essentially. So obviously step 1, work out your y-int. So that's when x equals 0. Work out your x-int, obviously when y equals 0. Check for stationary points. So that's obviously solving for y dash equals 0. And then check the nature using y dash dash. So is the second derivative positive or negative? That gives you a happy face or a sad face, or a stationary point of inflection. And then check any points of inflection, that is looking at the y dash dash. Looking at the domain, so in particular, if you were given a domain, then you would have to calculate the corresponding endpoints, the y value, so you know where to stop drawing your curve. If relevant, any asymptotes, so are there any values for which your denominator fails to, for which you don't have any x values, so you're dividing by 0, for example. And essentially look at the limits as the x goes positive and negative infinity. So this is looking at, well, what are the long-term behaviors as your curve reaches very, very right and very, very left. So those are 1, 2, 3, 4, 5, 6, 7 steps you should check when you're sketching a curve.